Well, hello everybody and welcome to October's Virtual Planetarium with Pete Lawrence and me, Paul Abel. And we are going to start, as we always do, with the inner solar system and the planet Mercury, which is available. It's not very well easy to see, though. Best time to catch it is October, the start of October, where it's visible 40 minutes before sunrise. But around that time, it's quite tricky. But as October progresses, the situation decreases even further, doesn't it?
Yes, it does. On the 7th,
it's hopeless.
On the 7th of October, it's about magnitude minus 1.1, rising an hour before the sun. But despite brightening, the sun's glare engulfs the planet rapidly after this date. Superior conjunction occurs on the 20th of October, after which Mercury returns to the evening sky when it'll be poorly positioned after sunset, setting with the sun.
So Mercury, quite a challenge. So we'll move on from that. Next planet out, of course, planet Venus. We had a great evening elongation for Venus at the start of the year. That finished in August when Venus reached inferior conjunction and is now in the morning sky. You really can't miss it. It's very, very bright.
Yes,
magnitude minus 4.4. It reaches greatest western elongation, so it's its furthest point from the sun on the western side of the sun on the 24th October, separated by about 46.4 degrees. So that's quite a good angular separation.
It is, and it gets there pretty quickly, doesn't it, after sort of going through inferior conjunction, which, as you say, was in the middle of August. It disappeared from our evening skies quite rapidly, and I'm always interested in how that happens, actually, because it's a very prominent addition to the evening sky, and then it sort of disappears quite rapidly, and everybody who's got used to it sort of forgets about it.
It is a strange thing. One of the things I notice about it is because I tried to follow it right up to dichotomy when it's 50% illuminated, then not long afterwards. What you tend to find about that time is, particularly if you live in the UK, you get a cloudy, wet couple of weeks.
Yes.
It's surprising then when you come back how quickly the planet has fallen towards the sun. And it only takes a couple more weeks, and before you know it, the elongation's practically over.
Yes.
It falls towards the sun very, very quickly. So
it does indeed, yeah.
Make the most of it. So through the eyepiece on 1st of October, the planet is still a crescent, 36% illuminated, 31 arc seconds across, so quite large. But by Halloween, 31st of October, the phase is much larger, 54%, because the planet's moving away from us.
Okay, and of course, its 50% lit phase should occur at western elongation, but normally, due to the phase anomaly, it should be a few days late, if the phase anomaly actually exists.
Yeah. So Peter and myself have been doing some observational work on this, and we have both managed to eliminate the phase anomaly, him from his images and me from my drawings. So I think we're not saying that the phase anomaly doesn't happen. It does happen, but you can remove it. So that means it's an artifact of Earth-based observation rather than any effect of the Venusian atmosphere, which I think is true because no other planet shows it. So I think it is an illusion, really, rather than...
I mean, we've got a lot of work to do on what we are trying to work out, but I think the effect really occurs because of the way the illumination on the planet's disk falls off towards the terminator.
Yeah, I think I agree with that. The reason I think this works, the method I use for reducing this anomaly by using quite a small aperture, what happens is that the terminator shading becomes much more granular, and
yes.
as a result, the terminator becomes much sharper, which means you can see the phase properly. It's quite a lot in a big telescope. The terminator of Venus visually is quite fuzzy. And I think this is where the phase anomaly is coming from visual point of view. In images, of course, it's slightly different.
Well, yeah, but even then you see the fact that there is a massive difference between the fully illuminated part of the planet and the terminator edge is where the problem is, and you have to be extremely careful, because if you start to adjust the camera settings, you can overexpose Venus so that you start to get blurring, if you like, of the edge. It starts to overexpose and gets bigger than it should. So you have to keep the exposure right so that doesn't happen. But you have to change the way the camera sees the planet so that it brings out everything that's illuminated. And when you do that, you find out that the phase anomaly is not quite as strong as you would imagine it should be. But as I say, we've still got some work to go on this.
We have, but it's fairly clear in my mind that it's largely an artifact of Earth-based observation rather than anything to do with the atmosphere of Venus. Although, of course, the atmosphere of Venus is causing the boundary of the Terminator to look fuzzy. So, but that's, I think we've managed to show, Pete, that it is really an artifact from looking at it from the Earth.
Yes.
Okay. Well, let's move out then. Mars, very straightforward, not visible this month. So, I suppose we're going to have to... It's finally given up the ghost and we'll be back later on next year. But planet Jupiter, the next one out, very, very good now. Noticeably higher than it has been for the last couple of years. It's in the constellation of Aries. Quite a bit to see. 75mm telescope or larger will show you plenty on Jupiter's disk.
And wow, I mean, it reaches opposition Jupiter next month on the 3rd of November. And throughout October, I've been really well placed for viewing from the UK, able to reach an altitude of 51 degrees, which, as you always say, from the UK, we'll count that as being overhead.
Practically overhead, practically at the centre.
And it's also really bright as well, which will be fantastic for taking images of it, because it'll reach magnitude -2.8. And that's a consequence of the fact it's fairly close to Earth, or in terms of Jupiter anyway. So that's a great opportunity to get out there and experience this amazing planet. And it is an amazing planet to observe, isn't it? Because it rotates so quickly as well.
It does. And one of the fascinating things, Jupiter is quite unlike the Earth. It's a gas planet, and its atmosphere is so very dynamic. So new storms come and go. The Great Red Spot, which is a very long-lived hurricane in Jupiter's southern hemisphere, is not constant. It changes in size. Sometimes it shrinks. Sometimes it's moving quicker. And you get all these storms and all this beautiful chaos in the atmosphere of Jupiter. And a lot of this is visible in quite small apertures. So
yes, it is.
It really is the amateur astronomer's best friend. And if you're looking to start drawing the planets, I recommend starting with Jupiter, because if you can master drawing Jupiter in under 12 minutes, which is how long you can't go any longer than that to make a drawing, because otherwise the rotation's moved everything, then you'll be well on your way to becoming a good visual observer.
Absolutely. I think the amazing thing with Jupiter, actually, which I remember in my early days observing it, is how well the Great Red Spot hides from you.
Yeah, you can go for months without seeing it, and then because of the clouds here, the clouds and the rain here, and then finally you get... But it does work the other way, though. Last year, every time I turned towards Jupiter, every time we got a clear night, the Great Red Spot was always there. I got fed up with seeing it. I thought, well, I want to see the other side now. So,
we're never happy, are we?
Never happy. It's always something. We should also mention, of course, the Galilean moons, Io, Europa, Ganymede and Callisto.
Yes.
4 large satellites that frequently pass in front and behind Jupiter. No scientific value in observing them. That it really is spectacular, I think, to watch the shadow of a satellite of Jupiter pass across the cloud tops. So
actually, I think there's a new sport now with the especially if you've got a larger telescope and a high resolution imaging setup, and that is trying to image details on the disks of the moons.
Yeah, well, I've seen naturally Damien has done this, I think, with Ganymede. I've seen quite a few other people that not only do Ganymede but Io as well. I'm sure it won't be long before amateur astronomers are routinely imaging Io, and that'd be one way of keeping track of the volcanism and the long-term changes on the planet. So
it's really exciting, yes.
It's stunning when you think, when I was an undergraduate, you were dependent on spacecraft to show the details on Io, and now amateur astronomers are in the range where they can...
In the 1950s?
It's not the 1950s. That was when you were at University, Pete. I was
not in the university in the 1950s.
Well, whenever it was, the war years, whenever it was. It was the late 90s for me, 99. And you were very dependent, weren't you, on spacecraft images? So
yes.
Now we can do it ourselves. So wonderful
It's
stuff.
amazing how quickly everything has moved on. I mean, sometimes you feel very frustrated when you go outside and you don't get a very good season and your images haven't improved very much. But if you look back just a few years, really, from when Lucky imaging started in particular, and to where we've got to now with the really sophisticated, very sensitive cameras, etc., taking amazing pictures of the gas giants. The detail which we're getting is quite phenomenal, and it's easy to forget that sometimes. You get frustrated if the seeing isn't good or whatever, but if you do get good seeing, you can get some amazing results.
And breathtaking views as well. So,
yeah.
Yes, all true. Okay, next planet out, Saturn. So it's now well placed in the evening sky. Well, it's certainly better than it was.
Yes.
Higher in the sky. The rings are now quite shallow. I had a look at Saturn a couple of nights ago, and the rings are quite well closed up. And although that means we're losing details in the rings, this does mean that we get chances now to see satellites of Saturn, Titan, Tethys, Dione, the bigger ones, passing in front of and behind of Saturn. That's quite rare. In fact, I have never seen a transit of Titan. I don't know if you have, Pete, but I've never
have you not?
Never.
I do remember, actually, the last time this happened, and every transit of Titan was badly timed from the UK.
I know. That's why I didn't see it. That's why I didn't see it. But there was a ring plane crossing in the mid-90s, I think. Again, we just didn't have enough clear skies. I had a 4.5-inch reflector at that time, but I think I never came across a Titan transit. So I don't know if you have an image of one, or have you ever seen it?
I've never seen a Titan transit, as far as I remember. I remember the ring plane crossing, the last one, which was that around 2007-ish, around that time?
Something like that, yeah. 2008, 7, something like that. Yeah.
But it happened when Saturn was very close to the Sun, of course, which made it even worse to see. It's like Saturn doesn't like us, isn't it? It just, as it gets higher in the sky, the rings close up, and then when you think, okay, well, I'll watch a ring plane crossing, it gets really close to the Sun, so it hides itself. Maybe it's shy.
Maybe it's shy, doesn't want to reveal all its secrets. That could be it.
Yeah. Okay.
We should say there's a bright waxing gibbous moon appears near Saturn on the evenings of the 23rd and 24th of October. So that's a good way of finding Saturn if you're having difficulties. Although it is quite bright, so it should be too difficult.
Unlike the next two, Uranus and Neptune. Well, Uranus is now in its best position due south under astronomically dark skies. The best time to see it is probably 31st of October at about 0250 UT, when it reaches an altitude of 55 degrees, which is pretty. That is overhead, isn't it?
That really is.
It's magnitude plus 5.7, so theoretically visible with the naked eye, but it is tricky to do that. And as we've said before, one of the difficulties in seeing Uranus with the naked eyes is the fact that you have other stars close by which are of similar brightness, and you're never quite sure if you've got the right one when you're looking at them. But binoculars will show it very clearly.
And in a telescope, of course, the disk is very, very obvious, even at low power, I think.
Yes, it is, yeah. Especially, as it gets towards opposition, it'll be nearly 4 arc seconds across, which is not bad at all. On the 31st of October, it sits 2.2 degrees south-southeast of mag plus 4.3 Botine, which is Delta Arietis. So that's a good way to find it, actually. That's probably the best navigational aid. And Neptune, well, that's best to see at the beginning of October. 2nd of October at about 0015 BSTs when it's due south, and it'll reach an altitude of 34 degrees. Magnitude plus 7.9, not much to see with smaller equipment, and even larger telescopes will only show limited detail with it. But you can see the disk of Neptune, you can see its colour, this bluish colour, and you can see its largest moon, Triton, as well, which is surprisingly easy, isn't it?
It is. It's surprisingly bright, actually. With my 12-inch telescope, I sometimes have fancied that I could see slightly darker bits of Neptune's disk, but I'm never 100% sure. And there's no point in trying to compare with images because they're often fuzzy because Neptune's quite a long way away, and so you can see anything you want. So I'm still not sure I've ever seen anything on the disk of Neptune. I have seen the disk, and I have seen it's quite a strong bluish colour, but I wouldn't claim to have seen anything else.
You need to have really good seeing to get anything with visually or image-wise, because it's so small.
Yeah, you do. Okay, well, we got some specials. We have specials every month, and this month is no different. On the 3rd of October, as dawn approaches, an 82% lit waning gibbous moon lies 1.7 degrees south of the Pleiades. That's always quite a nice pairing, actually.
It's something, actually, with a moon that bright, you might actually miss the Pleiades completely.
Yes.
But the way to see it is to use binoculars. Just look at you'll be blinded by the moon, of course, but you will be able to see the cluster stars.
Yes. On the 5th, Ganymede's shadow, so Ganymede is the largest satellite of Jupiter. In fact, it's larger than the planet Mercury, so it's very large. The shadow of the satellite transits Jupiter near to the planet's south pole, so that's at the top in a normal inverting telescope. The event starts at 21:46 UT and concludes at about 23:52 UT, so that'll be fun to watch. They're incredibly noticeable shadows of Ganymede. Have you seen? You must have seen dozens of them, Pete.
Yes, I've seen loads of those. Yeah, and actually on the 6th, you'll get Ganymede transiting Jupiter. It's part of the same event actually, because Ganymede transits Jupiter from 0057 UT until 0222 UT. And Io in its shadow also will be transiting towards the end of that event. So plenty to see with the moons interacting with Jupiter, which is always lovely. On the 7th, we've got a Claire obscure effect. Don't know if you've seen this, Paul, known as the Cutlass.
No,
and that's
quite by accident, Pete. You've managed to put in something I've never heard of.
Oh, right. Okay.
No, what is the Cutlass? What is it?
It's an easy one. It's where the straight wall, or Rupi's rector, is the blade, and then you've got I think that it's an unofficial name, the curved mountain range at one end of it is called the Stag's Horn Mountains, I think.
Yes, that's right.
And that's the handle.
I see. So there has to be a bit of shadow, presumably, or is this... Otherwise,
yeah. Well, you could see it without shadow, to be honest, but I think this is when it is particularly strong.
Right, and for those of us who don't know what a cutlass is, because we weren't born in the 19th century, what is a cutlass?
It's a sword.
Oh, I did not know that. I didn't know.
You must have seen some swashbuckling pirate films.
Yes, but they don't say, here's my cutlass, and then start using it, do they?
I bet they do.
They do not. Well, they don't in the ones I've seen anyway. No, I didn't know it was called that. I just thought it was called sword. But anyway, I could now you've explained it, I could see how that could work. Okay, on the 8th, we have the Draconid meteor shower reaching its peak, and that starts in the night and works its way through into the following morning. Best chances are, of course, when the radiant, where the meteors appear to come from, are higher in the sky as the sky darkens in the evening. It's about 8:30 BST, so that's 9:30 UT.
The Draconids are that's the one that is also known as the Jacobinids, isn't it?
Yeah, I think so, yeah. Can't remember why.
Yeah. Because of it's Comet Jacobini Zinner.
That
is the parent.
Yes, that would make sense. Okay, on the 10th, the southern Taurid meteor shower reaches its peak. I don't think I've ever seen any meteors from the southern Taurids. But
the Taurids, there are two branches, the southern Taurids and the northern Taurid branch. And the ZHR is 5 of each of them.
Right.
But they are known for producing bright trails, fireball events. I remember one year there were a lot of fireballs which were seen associated with the Taurids, so they're always worth keeping an eye on.
Okay, all right. Well, that's quite exciting if you get these bright fireball events. On the 11th...
And they have really broad peak as well, so that it's not like the Perseids, which is just a few hours long. It's several nights long.
Oh, so...
Mind you, at 5, you probably wouldn't notice much difference, but... Yeah, there's plenty of opportunity.
Oh, yeah, that does give you a bit more opportunity, particularly as October can be quite cloudy. Okay, on the 11th, the bright moon moves out of the way. This is a good time to look for the binocular comet 103P Hartley 2, which is currently moving through the constellation of Gemini, and it's expected to reach magnitude 8.3. That's quite... For a comet, that's quite bright. So
not bad at all, is it?
No, it's not. I know some folks like to think of comets are only interesting when they're very bright naked eye objects, but that's not true. Telescopic and binocular comets are also very, very fascinating. And it will be interesting to see whether this gets as bright as magnitude 8.3. Maybe it gets brighter, or maybe it doesn't get as bright. But whatever it does, I'm sure it will be fascinating.
And do remember that is an integrated magnitude. So that's the light of the comet squished into a point source like a star. So in real terms, when you look at it, it'll look fainter than you would expect to see an 8.3 star.
Yeah.
That makes any sense.
It does. It does. And in fact, that's how I estimate the magnitudes of comets. I defocus the telescope, so the stars are about the same sort of size as the comet. All right, on the 13th, we have more Galilean shadows. Ganymede's shadow once more transits Jupiter's southern polar region, this time between 0147 UT and 0352 UT. So another chance to see that. And Io's shadow is also in transit from 0343 UT onwards, and this will create a double transit shadow event.
It's quite a short overlap, actually, when both of those are there. It's only 0343 to 0352, but it does count.
It does count, and that's the time to grab an image or make a drawing. Actually, you just have time to make a drawing in that 10-11 minute slot, though. That's right. It's just quite tricky, but yeah, it can be done.
Well, there is another opportunity, actually. On the 20th, a double Jovian shadow and moon transit occurs as dawn breaks at 0538 UT. Io's shadow transit begins. Ganymede's shadow transits from 0548 UT. Io transits at 0602 UT. And Ganymede at 0732 UT after the sun has come up.
Okay. Well, actually, that's not such a tall order, is it? Because if you've got...
I've observed Jupiter during the day.
So have I, actually. I've only ever done it when Venus and Jupiter have been in, conjunction nearby. Yeah, but you can see some detail. But I guess it's more about contrast than fine details, isn't it? So
yes.
If you've got shadows on there, they'll be quite obvious, probably even in daytime, I should think.
Yeah, shadows help. Okay, on the 21st, we've got the Orionid meteor shower, which reaches its peak at around midnight. That has a ZHR, if I remember correctly, what's that? It's about 25 meteors per hour, the Orionids.
Yes, a few more.
But, it's a nice shower to look out for. On the 28th, we've got a partial lunar eclipse, but don't get excited about this because it is really quite a small partial lunar eclipse. It's just a tiny bit of the moon which is covered by the Earth's umbral shadow. But you will see the shading because you've got the penumbral part, which is quite dark as it gets close to the umbra. And you will see a tiny little nick coming out of the bottom of the moon. Is it the bottom? I can't remember. Look into the magazine; all the details are there for that. But it is a tiny, tiny partial eclipse.
We haven't had a proper lunar eclipse for ages, have we?
No, we haven't.
A big one. So, it's better than nothing. On the 29th, the British summertime ends at 0200, so we don't have to worry about converting between British summertime and UT. The wretched British summertime is gone. Although, weather-wise, I don't think British summer ever got started, did it? But never mind. Also on the 29th, moon occults magnitude 4.3, Botine, Delta Ariatis, that Pete mentioned earlier, from 2310 UT. Onwards.
And on the 29th of October, Io will transit really close to its shadow in the morning. Because Jupiter's close to opposition, the shadow and the moon tend to line up. And so that's something really well worth looking out for. And you'll have Callisto there as well. Callisto's orbit is so large and Jupiter tilted to such a degree that it's not actually moving in front of the disk. But Callisto will be poised directly under Jupiter's southern pole, watching the Io transit, no doubt.
Should have some nice views of the Io transit from Callisto.
Yes, that's right. And on the 31st, we've got another one, Io and its shadow transit. And this time they're really close together because opposition's just a few days away. And that one is in the evening, the event starting at 2031 UT.
Okay, well, let's now move out into the night sky. And October is a bit of a mishmash, isn't it? Because we've kind of got 3 seasons, summer, autumn and winter, all together in the evening sky.
Yes, you have. So we've got the summer triangle still. Well, summer triangle stays up forever, doesn't it? Almost. It's still visible through to December, but of course we lose the southern one as we go through into the winter months, which is Altair. but Vega and Deneb, I think they're just about circumpolar from the UK.
They are, I think, yeah.
Yeah, and if you look up in the east, you'll see the stars of winter, which are climbing ever higher. And that's sort of marked for me, I know it's sort of on the transition with autumn, but by the Pleiades and Taurus.
Yeah, I remember Patrick used to say whenever he saw the Pleiades in the evening sky, he knew winter wasn't far away. No. And it is true. You do associate seeing the Pleiades with winter. So, yeah, it's a good pointer that winter is on its way.
Yeah. Well, summer and winter are connected by a ribbon of faint starlight, which is the Milky Way, of course. And if you look over towards the west again, where you've got the summer triangle, you should be able to see the Milky Way. You've got really dark skies flowing up to the cruciform shape of Cygnus the Swan, the centre of that known as the Northern Cross. The Milky Way runs up the central spine of the cross, eventually leaving the Swan north of Deneb and entering neighbouring Cepheus the King.
Yes, this is an interesting little constellation. It kind of looks like a small house with a very pointed roof, the little square.
It's a child's drawing of a house, it's always described as.
No, it's not always described as, Pete. Only you ever describe it as that. That's not always. But yet...
Well, I always describe it as that.
Yeah, that doesn't mean everyone else does, but it is actually a good description because it's kind of got that really oversized roof on it.
Yes.
It's not a massive constellation, but there are some interesting things in it. For example, the red star Mu Cephei, which is really quite a pretty star. It's known as Herschel's Garnet star.
Yes.
One of the brightest, largest stars of its kind that can be seen. It's a red supergiant, about 1,420 times larger than our own sun, and quite a lot more luminous as well.
It's about 350,000 times more luminous. In fact, you mentioned it's called Herschel's Garnet Star. I think it's got a name as well. It's called Arrakis, which always reminds me of Dune.
Yes.
If you're a science fan, which is Arrakis, of course. Yeah, it is an interesting star. It's very red, actually. It is quite red. It's variable as well, isn't it? It varies between plus 3.6 and 5.0 over a period of 2 to 2.5 years.
Yes, so, it's one of these long period one of these long period red giant stars. The surface expands and contracts over time, causing it to brighten and fainten over time.
Okay, well, from Cepheus, the Milky Way flows into Cassiopeia, the seated queen, both royals occupying the area of sky close to the zenith at this time of year. So it's a good time to scan them for deep sky objects. And Cassiopeia, in particular, is very rich in open clusters, so a slow binocular sweep across that region will keep you occupied for hours. From Cassiopeia, the Milky Way flows into Perseus, the Greek hero, and between the pair lies the wonderful double cluster H and Chi Persei, which I think is probably best suited for binoculars. They bring it out beautifully, don't they?
They do. As I mentioned earlier, I got a new 80mm scope. I'm looking forward to seeing this the double cluster in that telescope, because, as you say, the best views to be had are in binoculars and a small telescope. I think it's because if you look even with a large telescope on low power, you lose parts of the cluster, whereas if you look with a smaller instrument, you can see both of them in the same field of view. And I've always described it as looking like spilt sugar on a black velvet cushion.
Right. Below Perseus, the Milky Way flows through Auriga, the charioteer. And here you'll find more wonderful clusters, including M36, M37 and M38. They're not listed in that order, actually, in the constellation, which has always bothered me slightly. But they look quite interesting. They're quite faintish, so you need to use binoculars to pick them up. But they do stand out fairly well. But I guess before we go on too long, we'll bring us to a conclusion soon. We need to mention the centrepiece of the autumn sky, which is, of course, the Great Square of Pegasus, which is very high up at the time we're talking about at this time of year. And although the stars aren't particularly bright, the shape as a whole is quite distinctive, isn't it?
It is. It's not really a square. But
no, it's not.
I suppose that the square Pegasus is easier and more catchier than the irregular polygon of Pegasus. But
it's not all the stars in it belong to Pegasus either, do they? The one in the northeast corner is Alpheratz, which belongs to Andromeda. It used to be called Syrrha, which was, I think it was Delta Pegasi.
It makes more sense for it to be in Pegasus because that's part of the square. But as you say, it is quite distinctive once you find it. It's actually a lot bigger than most people think. It's quite a big constellation. And if you look in the centre or in the square Pegasus, see how many stars you can see, because that's a good measure of how bad light pollution is or isn't in your area.
If you live in a city, you're likely not to see any stars in the centre. If you live in sort of lightly light polluted area, you probably see, I don't know, somewhere between 2 and 10 or so stars. But this is quite remarkable. I was reading about this the other day. Do you know what the record is?
No.
102.
102? Someone sat and counted 102 stars?
Yes.
Well, you say living in the city. I have counted about 8 or 9 stars
okay.
on us here. Because what's happened in a lot of cities, thankfully, is they've been putting in new lighting, replacing the sodium light with proper downward shining white lights. So that's increased the...
That's really quite encouraging.
It is quite encouraging, and councils that do this are to be congratulated because the night sky is there for us all to enjoy and should not be polluted and lost to ugly, unnecessary light pollution.
What a lovely sentiment. And with that, I think we'll bring everything to a conclusion. So thank you very much for your time, Paul. Very interesting as ever, and wishing you clear skies.
Thanks, Pete.